We have to solve second order non-homogeneous differential equation. So at first we're going to find complementary solution. So for this we're going to make a homogeneous equation. So we set left hand side equal to 0, and I'm going to substitute it as m, so we can make a quadratic equation. So it's going to be m squared plus 1 equals 0, and from this we get that m equals I and negative I, and general form for this solution is m equals alpha plus or minus beta I. Therefore, form for complementary solution is e to the power of alpha x times c1 cosine of x plus c2 sine of x. So if we substitute instead of alpha 0, because in our case alpha equals 0, we get e to the power of 0, which is 1. So complementary solution is c1 cosine of x plus c2 sine of x. And now we're going to find particular solution. So formula for this is y equals u1 y1 plus u2 y2. In our case, y1 we get from here, so that's going to be cosine of x. y2 is sine of x. And also we're going to write g of x, which is our right hand side, which is sine of x. So now we're going to use front scan to find u1 and u2. So front scan of y1, y2 is determinant of y1, y1 prime, y2, y2 prime, and that's going to be determinant. So we take determinant of cosine of x, sine of x. Derivative of cosine of x is negative sine of x, and derivative of sine of x is cosine of x. And that's going to be cosine of x times cosine of x, it's cosine squared of x minus negative sine squared of x, and that equals 1. So now we can find front scan first. This time we take determinant, but instead of y1 we have 0, y2 stays the same. Instead of y1 prime we have g of x, which is sine of x, and here we have derivative. Therefore that's going to be 0 minus sine squared of x, and if we want to get rid of power, we can rewrite this as negative 1 minus cosine of 2x over 2, and if we split this up we get negative 1/2 plus 1/2 cosine of 2x. Now we're going to do the same. So now we're going to take determinant where y1 is cosine of x. Instead of y2 we have 0, here negative sine of x, and here just sine of x. So that's going to be cosine of x times sine of x minus 0, and we can rewrite this as 1/2 times 2 sine of x cosine of x. So this expression equals sine of 2x. So knowing this, we can find u1 and u2. So formula for u1, we should take integral of Wronskian 1 over Wronskian dx. So we substitute this and we get negative 1/2 plus 1/2 cosine of 2x over 1. So split this and I get negative 1/2 integral of dx plus 1/2 times the integral of cosine of 2x dx. and therefore we get that u1 equals integral of dx is x, and integral of cosine of 2x is sine of 2x, and we have to multiply it by 1/2 because of coefficient in front of x. And therefore we get that u1 equals negative 1/2 x plus 1/4 sine of 2x. Now we're going to do the same and find u2. That's integral of Wronskian over Wronskian, and that's going to be 1/2 sine of 2x in the numerator and 1 in the denominator. So we take constant out of the integral, and the integral of sine of 2x equals negative cosine of 2x and times 1/2. Therefore we get that u2 equals negative 1/4 cosine of 2x. So now we're going to make particular solution. So that's going to be u1 which is negative 1/2 x plus 1/4 sine of 2x times y1 which is cosine of x plus u2 which is negative 1/4 cosine of 2x times y2 which is sine of x. And now we're gonna expand brackets and we get negative 1/2 x cosine of x plus 1/4 sine of 2x cosine of x minus 1/4 cosine of x sine of x, cosine of 2x. And that's gonna be a particular solution. So general solution, simply the sum of complementary solution and particular solution. So general solution is y equals c1 cosine of x plus c2 sine of x plus minus 1/2 x cosine of x plus 1/4 sine of 2x cosine of x and minus 1/4 cosine of 2x sine of x.